Good day everyone. Today we will start our first lesson for CC203 or Programming 2. For today's lesson, we will start with strings and vectors. As a continuation of the previous book that we have used for this programming subject, we will resume with chapter 11, hence the chapter for strings and vectors. For this chapter, we will be talking about the following: an array type for strings, the standard string class, and vectors. Talking about array type for strings, it is said that C strings can be used to represent strings of characters. Thus, C strings are stored as arrays of characters. Also, C strings use the null character /0 to end a string. If you will recall from our previous course during our programming 1, we've already been introduced to the basic concepts of arrays. At that time, we were only introduced to arrays which are of fixed size. For this unit and for this chapter, we will be learning about arrays that can be dynamically resized, which means we can increase or decrease the size of an array during runtime or in a dynamic manner. Going back to C strings, we can declare a C string variable in the following way. So for example, we can declare a C string variable s with the size 11. As to the details of C string, declaring a C string as character creates space for only 9 characters. It's because the null character which terminates our C string requires 1 space, hence terminating character. Also, a C string variable does not need a size variable. The null character immediately follows the last character of the string. Let's take a look at this example. As you can see here, the entire size of the C string variable was not consumed. As we can see here, following the last character in this string is the terminator, which is in this case the character located at index 7. Now, how do we declare a C string? In this case, we use the following syntax. For example, we provide the data type, the C string variable name, and of course, the size. In this case, we indicate it as the maximum string size plus 1, which will accommodate the terminator as we have seen in the previous slide. Thus, plus 1 reserves the additional character needed by /0 or the terminator. How do we initialize a C string? To initialize a C string during declaration, we simply do the following. In this case, we specify the C string variable name, the size, and of course, we simply use the assignment operator to provide it with an initial value, in this case, the following string. And of course, the terminating character is automatically added after the last character of our string. Another alternative that we can do is, of course, to initialize our C string in the following way. However, we can do that using this one. Talking about C string errors. As we can see here, this attempt to initialize a C string does not cause the terminating character to be inserted in the array. As we can see here, this is a C string which is intended to have 3 characters. We can't do that. Thus, do not replace the null character when manipulating indexed variables in a C string, otherwise that would result in an error. If the null character is lost, the array cannot act like a C string. For example, we have the following. As we can see here, this code depends on finding the null character. Therefore, if it won't be able to find the null character, as what we have seen in the previous slide, then this would probably generate an error or cause a logical error in your program. Thus, another way to do that is the following. It would be better to use this version in case the terminating character cannot be found or had been removed. In this case, we will also look if the index size of the C string has been reached. Thus, it will be a safer way of implementing the code that we have seen in the previous slide. Now, how do we do assignment with C strings? For example, this statement is not allowed. This is an assignment statement and not an initialization. Therefore, the assignment operator does not work with C strings. So how do we do the assignment of C strings? A common method is to assign a value to a C string variable by using the predefined function Sdrm Copy defined in the C string library. For example, as we can see here, we declare the C string library to be included in our program, and of course, we declare our C string variable with the following size, and in this case, we use the predefined function Sdrm Copy by using the previously declared variable and of course the string value that we wish to assign to our previously declared variable. Therefore, it places the string hello into our declared variable, which is a string. However, there is a problem with such function. Sdrm Copy can create problems if not used carefully. It does not check the declared length of the first argument. Thus, it is possible for Sdrm Copy to write characters beyond the declared size of the array. And of course, we don't want that to happen in our programs. That would generate errors. So the solution for that is to have another version which is safer to use. Thus, from Sdrm Copy, we can use its safer version, which is the Sdrm Copy. It uses a third argument representing the maximum number of characters to copy. Thus, it assures us that we will not exceed the maximum capacity of the original variable that was declared by specifying the maximum number of characters that the variable can contain. Here's an example. This code copies up to 9 characters into another string, leaving 1 space for the terminator character. Please take note that we count its index from 0, thus 0 to 9. Here's another alternative for C strings. First, we must take note that the equality operator does not work as expected with C strings. The predefined function Sdrcomp is used to compare C string variables. thus allowing us to do this. As you can see here, we would like to compare two C-string variables. And in this case, if they are not of equal content, the following will execute. Otherwise, the following will be displayed as output. So what is the logic behind this? Sdrcomp compares the numeric codes of elements in the C strings one character at a time. If the two C strings are the same, Sdrcomp returns 0. Thus, 0 is interpreted as false. As soon as the characters do not match, Sdrcomp returns a negative value if the numeric code in the first parameter is less. It also returns a positive value if the numeric code in the second parameter is less. And non-zero values are interpreted as true. So that's how Sdrcomp works. Now let's talk about more C-string functions. Again, the C-string library includes other functions such as strlen, which returns the number of characters in a given string. And this is an example of how we can use it. strcat, which concatenates two C strings. The second argument is added to the end of the first, and the result is placed in the first argument. To do that, we can use it in the following manner. Talking more about the Sdrm cut function, it is said that it is the safer version of the strcat, although they serve the same purpose. A third parameter specifies a limit for the number of characters to concatenate. For example, we have the following. And of course, these are some of the predefined C-string functions that we can use. So please take a look at their description and of course their cautions, so we will know what are the possible issues that we might encounter when we use them. And there you have it. Of course, we can use C-strings as arguments and parameters during a function call. Basically, C-string variables are arrays. Also, C-string arguments or parameters are used just like arrays. If a function changes the value of a C-string parameter, it is best to include a parameter for the declared size of the C-string. Otherwise, if a function does not change the value of a C-string parameter, the null character can detect the end of a string and no size argument is needed. Let's talk about the C-string output. C-strings can be output with the insertion operator, just like the following example. As we can see here, we declared and initialize a C-string variable with the following content. And we can simply display its content using cout, just like this one. And for the input, of course, we can also use the extraction operator to fill a C-string. Of course, whitespace ends the reading of data. For example, we can do the following. We declared the following C-strings, and of course, using cin, we were able to fill in whatever input right into our declared C-string variables. And of course, using the insertion operator, we will be able to display its output, just like this one. Now, how do we read an entire line with C strings. Let's take a note of the predefined member function getLine, which can read an entire line, including spaces. GetLine is a member of all input streams, and it has two arguments. The first is a string variable to receive the input, and the second one is an integer, which is usually the size of the first argument, which would specify the maximum number of elements in the first argument getLine is allowed to fill, thus making sure that we appropriately fill in the first argument only up to its maximum capacity. So how do we use getLine? The following code is used to read an entire line, including spaces, into a single C-string variable. For example, we have the following source code. If we will run this will produce the following output. Of course, getLine stops reading when the number of characters, last one specified in the second argument, have been placed in the C string. One character, as we've already known, is reserved for the null character. Also, getLine stops even if the end of the line has not been reached, which means as soon as the null character has been reached, getLine would stop reading whatever is in the input stream. C-string input and output work the same way with file streams. Thus, it is compatible when we work with files. For example, we can replace cin with the name of an input file stream, such as this one. To do that, we can implement using cout with the name of an output file stream, such as this one. And of course, from what we have seen in the previous examples, they all follow the standard syntax for the getLine, such as this one. We must take note that cin can be replaced by any input stream, just like what we've seen in the previous examples. And of course, to make sure that a space is reserved for the null character, so we always add 1 to the maximum capacity of our declared string variable. Now, we can also convert C-string to numbers. Let's take the following cases. In this case, we have the 1, 2, 3, 4, which are enclosed in quotes, which is considered a string of characters. In this case, 1, 2, 3, 4 is considered a number. When doing numeric input, it is useful to read input as a string of characters, then convert the string to a number. Why? In a real-world scenario, it is possible that we might encounter user inputs which might involve a $sign. Thus, we must process the input as string first in order for us to extract the numeric part of the said input. So how do we convert C strings to integers? To read an integer as characters, we read the input as characters into a C string, thus removing unwanted characters. We also use the predefined function atoi to convert C string to an int value, thus leaving us with integers. Here's an example. In this case, this example would process the string and return the integer 1, 2, 3, 4. In this case, this example would return 0 because the pound sign is not a digit. Of course, we can also convert C-string to long integer. This will have the same logic, but in this case, the predefined function that we will use is this one, the ATOL, which also returns a value of type long or long integer. We can also convert C-string to double, which is of course a floating point data type. In this case, we will use the following function, ATOF, which would return a value of type double. Here's an example. Now let's talk about the library cstdlib. As you can see, the predefined functions that we have mentioned so far are found in this library. Thus, to use the functions in this library, we simply include the directive such as this one. We now know how to convert C strings to numbers. So how do we read the input? There are various ways to do that. So let's take a look at this example. In this case, program 11.12 would read a line of input using the function read and clean, then discards all characters other than the digits 0 through 9, and use A2OI to convert the cleaned up C string to integer. Let's take a look at the example. So here it is. As you can see here, we have the following function, read and clean, which will discard all symbols except the digits. So therefore, we will only want to extract the numeric character from our input. And of course, we have here a helper function, which will discard all the input remaining in the current input line. So this is how we are going to use the function. Here it is. And this is how the read and clean works. As you can see, the following sample program has been provided with source code. So for you to see how it really works, I encourage that you run the sample code that was provided to you. So let's take a look on how it works. Okay, so let's enter an integer and press return. Let's say we enter 12. Okay, so you can see here, the string was converted into the integer 12. Let's try again. For example, I am going to enter this one. Let's see what will happen. So as you can see here, we only extract characters 0 to 9. As you can see here, the pound sign was ignored. So that's it for this example. So talking about confirming the input, the function getInt from display 11.3 would use read and clean to read the user's input, which allows the user to enter the input until the user is satisfied with the number computed from the input string. Here's another example. Okay. So let's run this example. Okay, let's input a number. Okay, that example is quite simple. As you can see here, it only what it does is to simply confirm the user input by using the following. Again, it uses the function read and clean to confirm the user input, and of course, as you can see here, what the read and clean function does is to extract numeric characters from the user input. That's all for this section, after which we will proceed with the next section.